Hi there, welcome back. Welcome back to video 2 in the restoration of this Graetz Baroness 610. When I finished off the last video, it was going very well. I was very pleased with the result. But there were a few things outstanding, quite a few actually, as I've come to discover. But no time like the present to get on with it. In this video, I'm going to check the selenium rectifier, probably replace it. The other thing is the alignment. I don't know what that little clip that flew off at the back there did to the alignment, if anything. So I'll have a look at that. I've got the service manual, so I can follow the instructions there. And yeah, this one's actually quite a lot of fun. Quite a lot of fun. Hope you enjoy it. I decided to go ahead and replace the selenium rectifier. Or I should say, I didn't replace it, I removed it and restuffed it with silicon diodes. Now, this is just 4 silicon diodes in a bridge configuration to replace the selenium equivalent. No big mystery there. I've actually done a video on how I do it step by step, so I'll link that above. And once this thing is back in place, you can hardly tell that it's been tampered with. What I did do is I wrote on the back that I restuffed it so that anybody in the future who opens this up will know that my grubby paws have been in here. Right, now what have we got? We've basically got a bridge rectifier now that's doing the same thing as the selenium equivalent with one difference. It's not dropping much voltage across it. Now if you know the theory, if you take an AC voltage that comes into a bridge rectifier, and let's say it's 200 volts, okay? The DC voltage you get out should be 200 times root 2. So 200 times 1.41 something, minus 2 diodrops, right? What you would get here is actually, 280 minus about 280 volts, if you take 200 as the input. What happens with the selenium rectifier is that you don't get 280, you'll get 260 or so, because it has a much bigger diodrop. So that's what we have here, and therefore we've had to play around with resistors. So I have the 2 AC lines going in there. The ground is connected normally, and the positive, the output of the selenium rectifier, I have coming out on this blue wire. Nothing's on, don't worry. It's coming out on this blue wire, and I've got 2 resistors in series here, and I'm measuring the voltage that's then going to the system, to the capacitors, to the first filter capacitor. This is actually our B1+. Now what I want to do is switch this on and show you what voltage we get on the voltmeter, on the multimeter, because I've already experimented a little bit with this. What I have here is the 220 ohm and 150 ohms, so 370 ohm. These things are very hefty. This is a 10 watt, so we don't have a problem with power. We do have a problem in that this is a bit precarious. If you touch any of that, you're going to get zapped. So I'm going to switch it on. I'll move back so we can see the multimeter, and I'll switch it on and see what voltage we're getting. But before we carry on, I just want to say thank you to our sponsors for this video. It's PCBWay, and you should visit their website. They're running the PCB big sales for Christmas, and if you need any of the services, there's certainly a lot on offer right now. If you go to the website, you'll see the Christmas coupons, a lot of discounts depending on the value of your orders, special offers, a lucky draw, and you can get some more coupons if you invite a friend to join. So visit the website and help our sponsors who help us. I have switched it on, and I've still got some limit on there. I've got the dim bulb limiter on here. What I'm going to do, I know there are no shorts. I'm going to bypass the dim bulb limiter and see what this settles at. We're supposed to have 243 volts or so. Now that looks pretty good. It's just a little bit high, which is perfectly fine. I have, as I said, 370 ohms on here. Now what I'm going to do is I'm going to replace this with one resistor. And this is a 390 ohm resistor. It's a 5 watt. Now is that enough? Well, let's find out. I'm going to just switch this off so I don't zap myself. And instead of measuring the voltage, the B+, I want to measure the voltage across these resistors. So what sort of voltage drop are we getting across here? Switch it back on. Let it settle. We've got about 17, 18 volts drop. Let's call it 20 volts. So the power that's being dissipated across here is V squared over R. So 20 times 20 is 400 divided by 370. Yeah, it's just sort of over 1 watt, I think it is. So not much power, which means that our 5 watt resistor should do fine. Now this is slightly higher, 390 as opposed to 370. I'll put it on there and see what voltages we get. Let me set that up quickly. We have the 390 ohm resistor in there. Switch it on. We should have slightly less than we had last time, but we were a little bit high. That is brilliant. 247. It'll probably come down another volt or so. So we are right on the ballpark. That's what we want. That 390 ohm resistor is going to do just fine. Now I'm going to fit it and bolt it or clip it to the chassis so that it uses the chassis to dissipate the heat. Got to be careful that I insulate the wires properly. Now how did I get here? Well, actually this is surprisingly high. Normally I get away with about a 50 ohm resistor. I tried the 50 ohm, it was way too high. I tried 100 ohm, still way too high. So I just kept adding resistors till I got the right one. And fortunately I have that resistor over here. If we try and see exactly what power this thing's dissipating, we take it from there and put it across the resistor. 18.5, again, call it 19 volts. So square that, divided by 390, that's our power. Well within the 5 watt that we have over here. Okay, let me finish this up and show you the result. And we're done. One more task complete. That resistor's clipped firmly with a little aluminium bracket that I made. This hole here, the screw here, was actually it's the same one that's holding the bracket that holds the ferrite antenna on. So I didn't need to make drill any more holes. Everything's nicely tucked away and protected with heat shrink. So we're good. That's done. It hardly looks like it's been touched except for that resistor, and it's pretty obvious. So that's one more task completed. And I have one more, which I did not mention. You can actually see it right here. I removed the dial glass and I've put in new tape. This is that cloth band-aid. They still sell them. I put them on all sides. The one that was here was really crusty, it just fell off. So that's nice and neat as well. Time to move on. All right, I think we're ready to do the IF alignment for the AM. Now this is very simple. It's 460 kilohertz going into the grid 1 of the ECH81 as per normal. And I have the meter, the AC voltmeter, detecting the voltage across the output, the speaker output. The speaker is connected, but it's connected to the dummy load, so we don't need to hear it, but we can see it over here. And I've got the signal pretty low, and I adjust the volume to where I get it about mid-range so that I can see the adjustment a lot better. And the ones we need to adjust are this one here, the ones closest to the antenna, this one and the one below, and that one and the one below. So let's see how we get along. By the way, the signal is a 460 kilohertz signal. It's got a tone, 600 hertz modulated, AM modulated, 30%. And it's going through, I've got the signal generator on minimum, which is 1 millivolt, 1 point something millivolt. But I've got like, what is it, 18, about 30 dB of attenuation. So it's a very, very small signal. You don't want to actually activate the AGC. Now, I think this is going to be fine because there's no wax on these things. So I think the previous guy did an alignment. See that? That was pretty much spot on. Yep, that's spot on. Let's see about this one. I'll go to the underside, but we've got a little bit on there. Very small amount of improvement. I'll try the ones on the underside, try not to get zapped. This one here. Be good if I could see it. Actually, it should be quite easy. There we go. Got just a slight improvement there as well. So this thing seems to be pretty well aligned. And again, I've got to congratulate the previous tech. Oh, we've got a bit there. No, that's something else. It's jumping into some sort of oscillation. I think it's because I'm moving this around. Can't get in there. It helps if you see the orientation of the core. These cores are pretty clean. No wax. Hardly anything. Well, that's pretty much it. That thing was as aligned as I've ever seen one. So the IF alignment for the AM is done. Wasn't much to it, was it? All right, next step. Since we are in alignment mode, let's do the RF alignment for the AM bands. I've got the signal generator producing the respective signals. The first one is at 550, well, I'll show you that in a second. 550 kilohertz. Amplitude is at minimum. And I've got a 30% modulation going on there with a 600 hertz tone. That's coming out of here. It's going into the switchable attenuator. At the moment, I've got 12 dB. I'm not sure how much I'm going to need. I've got the dummy antenna active. It's coming out of here into the AM antenna at the back. And that's all set up now for our alignment. I've got the speaker connected, and I've got the AC millivolt meter going on as well. So we'll be able to check the levels on that too. I found a way to put this up on its side without the faceplate touching, and it's nice and firm on the power transformer there, so it's easier to access the back. And the first thing you need to do is put it on medium wave. In fact, the first thing you need to do is to make sure that when you tune absolutely to the left, that it aligns with that bar over there. There's no point aligning the RF if your pointer is actually just shifted on the string a bit too much. So you can actually shift it on the string, you put it all the way to the left, or, down in this case, and you adjust the string. It sort of slips. There's a bit of paint on the back that holds it there. I had to crack it, and then you just slip it till it's perfectly aligned. And it is, I can see it now. First thing they tell us to do is to put it on medium wave. In fact, the first thing they tell us to do is to check the IF trap. That thing is completely sealed with wax. I don't think anybody's touched it, and I'm not going to touch it either. Medium wave, 550 kilohertz, feed in 550 kilohertz to the antenna, and adjust L133, L111. Now L111 is on the ferrite antenna. That also is perfectly sealed there with wax, so I'm not going to touch that. So to adjust the oscillator at the bottom end at 550 kilohertz, it's coil 133. Then we change that to 1.6 megahertz, so 1600 kilohertz. And they tell us to adjust C129. And then they tell us to go to 1450 and adjust C113. All those to a maximum. So let's set that up and get going. I've got the pointers set to exactly 550 kilohertz. And I can just sort of hear it. If I tune off, it's slightly off, very slightly off. Back to 550. And what we need to adjust is that coil 133, and that is this guy here. The way to identify these guys is actually quite simple. If you've got 3 bands of AM, like we have here, we've got long wave, medium wave, and short wave. Well, the way to look at it really is the long wave is going to have the greatest number of turns. So that'll be that guy there. The short wave will have the least number of turns, and that seems to be that one there. Medium wave, obviously, the medium number of turns, and that should be that one there. And because the sketch at the top is very dim, so I'm not quite sure that I'm right, but I think I am. So let me go back to 550. There it is, and we'll just adjust this guy here. See, that's just noise. There's obviously a station nearby, but I think that's where it is. Okay, that's 550. Then we have to change that to 1.6 kilohertz. So I'll change the signal generator, 1.6 kilohertz. We'll tune it to 1.6 kilohertz. That is right at the top there, over there. And now we'll put the volume up. It's not there. It's a bit low. So we want it there. And we have to adjust C129. And I believe that is, yeah, that's the capacitor just below the coil. So it's that guy over there. You sometimes have to sort of break the seal on these things with a metal screwdriver, but then obviously it's not a good idea to use a metal screwdriver after that. Just break the seal. It's sort of stuck on with probably a bit of lacquer. There we go. Perfect. Now we'll go back to 550. See if we are still on 550. Perfect. Okay, now they want us to set it to 1.4, I think it is, 1450. That'll be there. Signal generator to 1450. Are we on? Perfectly on. Perfect. We've done the RF alignment for the medium wave. Now for long wave, obviously we set it to long wave. And it's 150 kilohertz on the signal generator. And we go to 150, which is on the other side. I think we have to up the power a bit. Yep, we can hear it. At 150, it's just slightly out there as well. So I set it to 150 exactly. It's got a little notch there to mark it. And we have to adjust L134. L134, and as predicted, it's this guy over here. That sounds like it's perfectly tuned. Then we have to go to 340 kilohertz. Tune up to 340. It's just slightly out again. So we have to adjust the capacitor, or is it the coil? C114. Now C114 is this little guy over here. It's literally a little tube with some wires wound around it, and I don't want to mess with that. This thing is so close. It is so close that to go and unwind this to reduce the capacitance is not a good idea. So I'm leaving it like that. Right, next. Shortwave. Shortwave, 7 megahertz, L137. So 7 megahertz. It will go to 7 megahertz. Where is 7 megahertz? Down here. Again, slightly out. We'll just align it perfectly. And it's that guy there. There it is, you can hear it. And then we go to 17 megahertz and we have to do the capacitor down below. 17 megahertz, tune to 17 megahertz, which is here. Just off. Let's see if we can do that quickly. Break the seal. Watch where you put your fingers now. I don't see it. Hang on. This thing is very touchy. So I'm going to just put it, I tuned to it, there. I went just slightly closer to where I want. I can still hear the tone. And I'm just going to follow the tone now. There we go. I know I'm going the right direction. Just a little bit more. Take your time. Nearly there. It's just a hair's breadth away, but this is very sensitive. Where is it now? What's happening here? Hell, this is so sensitive. Okay, a bit closer. You can just hear the tone. It's about as close as it's going to get. 17 megahertz. It's not really getting much closer. This is really, really weird. This one is sensitive as hell. Okay, that's as close as I can get it. Okay, our RF alignment of the AM bands seems to be done. Now, obviously, I'm going to go backwards and forwards a couple more times on this on this shortwave one, because I'm not quite happy with the top end yet. But that's what you do, backwards and forwards. And that's our RF alignment of the AM bands done. Good. Okay, one more step completed. And talking about completed steps, look at this. This is a beauty. This is an absolute beauty. It came out perfectly. What did I do? Well, I wet sanded the paint off. Remember, the paint was just on the top and those sides, okay? The rest stays as natural Bakelite. And I had to try and match the color. This color has to be exactly like that, and it is. I mean, you're seeing a lot of glare, but it's exactly the same color as this trim. Now, I don't know whether that was the case when they started off. Remember, these trims do tend to yellow over time, but I think maybe the paint did as well. So this thing was matching perfectly, but it had a lot of dings, a lot of scrapes on there. So I sanded it all down with wet paper, wet and dry sandpaper. Very fine. I think it was about 800 grit. Got all the paint off there. And the reason I did that is when you use that paper, it does leave the Bakelite slightly roughened. So it holds the paint a lot better. And then it was a question of finding the right paint. And do you think I got it on the first go? No, I didn't. Do you think I got it on the second go? No, I didn't. I ended up trying this 3 times before I got the right color. The others were too light. They contrasted too much with the trim, and I wasn't happy. So I ended up doing this 3 times, and now I am happy. And this thing came out fantastically well. It was just spray paint, and it really was worth the effort, because, you know, no matter how good your radio is, if it doesn't look good, yeah. And these things are painted, so it's not a question of the wood gaining some sort of patina. You know, when something is painted and the paint scraped off, that's just paint that's scraped off. So anyway, I've also got the Baroness logo polished. The brass is nice and clean over here now, and that just goes in there. These things come with pins. It's got 3 pins on here. You just straighten them out, pull it out, and then when you put it in, you bend it, and that's how it holds in there. Most of them are like that. So this thing just goes in there, and you bend it at the back, and the enclosure is complete. The cabinet is complete. Okay, we're making progress here.
Selon Afrique Photo, on retrouve dans cette liste tous les cadres comme Ona Okambi, Abubakar.
Yeah, it's interesting to see what the reaction is. I mean, if they lose, he'll be accused of rotating too much, not enough of genius. But it just...
Retour dans ce groupe élargi, tandis que 4 nouveaux joueurs, la plupart binationaux, intègrent la tanière.
Предлог вновь ничего не оправдывает для ребенка неприятие.
Institute, National Research Council, Chulalongkorn University, and are just a handful of public sector organizations.
7 players in the Europa League, not all of them due to COVID-19, but a significant number. And the Premier League has actually written to the 20 clubs.
De relação com Deus por causa de uma outra razão que não é a observação do universo.
التي ستقود بكلامهم سأتحكم كثيرا على دراسة هذا الموضوع، ولكن الأهم من هذا أنه يرى بعض الخبراء أنه ليس من مصلحة
Claro, porque es que además al inicio de la pandemia, las familias ni siquiera podían despedirse de los enfermos. Allí llegaba gente nos lo contaban nuestros compañeros, nos ibais contando, era prácticamente una situación de guerra. O sea, que esto solo lo había visto la gente que había trabajado en países que había tratado, se había desplegado.
Sí, eso es solo el principio. Como he dicho, venía con muchas ganas, lo tengo que...
Sí.
Señor, eso no me entra en la cabeza.
No, sí, la verdad es que, pues...
Solo ante el peligro, ¿no?
Solo
Los mejores precios Pro para ayudarles con todos sus gastos. Tú llegas, cargas y todo.
No tanto hablar y demás, sino porque creo que somos, bueno, pues yo soy, como te decía, enfermera. Y yo lo viví. Una muestra de dar un paso.
Oui, bien sûr, parce que je savais pas comment ça allait se passer. Après, je savais très bien que j'étais sur... moi, personnellement, j'étais sur une bonne lancée, donc il n'y avait pas de raison.
Well, as you can see, this is quite an achiever. It's small, but thinks it's big, which is great. That's the way it should be. Reception on AM bands is exceptionally good, surprisingly good. The testing that I did on shortwave, you can see some of the reception there is amazing, all across the band. Obviously, on the lower frequencies, it's evening now, so some of the lower frequencies are better. But as we go down, medium wave, very full, very, very full. It's 9 in the evening, so very full, and a lot of stuff from North Africa, but most importantly, or more so than that, a lot of transmissions from the Canary Islands. There's one station here that people call me out every time. You hear one station repeated on medium wave quite a lot. It's a Spanish station. Some have mentioned that it might have to do with the mini whip antenna that I've got that's creating sort of ghost signals. It's not. The situation is this. I live in Madeira and it happens here. We have, for example, one FM station. One of the FM stations transmits on 4 or 5 different frequencies. Because we're hilly, they've got the main transmitter in Funchal, and you wouldn't pick it up on the north side of the island. So they have a repeater there. They have a repeater on the other end of the island. They've got a repeater here close to where I live. So we've got one station with 7 or 6 or 7 repeaters. It's the same station. It's just on different frequencies. And on the Canary Islands, they have the same thing on one particular AM band, AM station. They've got, I can't tell you now how many islands they've got, but they've got quite a few islands. And what they've done is they've got repeaters on these islands. Now, because I am away from there, and I probably shouldn't be receiving these things here in Madeira, but because I am away from there, across the sea, I'm getting the transmissions from every single repeater probably, except the ones maybe faced south with a mountain in between. That's why it repeats itself across the band. So that's perfect over there. On long wave, we got some stuff from North Africa. I couldn't quite get BBC Radio 4, but that's, yeah, I can hear it, but not close enough, not clear enough to listen to. Sometimes I get it, sometimes I don't, but I do get some other stuff. There's one here from North Africa, as you heard. So AM is brilliant. It's really brilliant. And that was the main problem with this radio. However, I'm not going to finish the restoration now for a simple reason that I have found some pretty strange instructions on the FM alignment, which I do want to do. The FM seems to be okay, but it's a little bit distorted, so I think it does need a bit of an alignment, maybe especially on that on the balancing circuit, the final IF transformer. But there's something strange in the instructions, and the service manual is not clear. It's very, very bad copy. I've tried to translate it. I've understood, I think, what they're saying. The front-end FM can is slightly different to what I'm used to. The place where you inject the signal is different to what I'm used to. So this is a bit of a learning curve here, which is great. There's also something really strange, and I've got to test it to see whether I've understood correctly. This thing talks about a 6.75 megahertz IF frequency for FM. I have never, ever seen that before. It's always 10.7, okay? This thing talks about 6.75. I've checked it there. It's what it says. It could be a bad, an error on the instructions. I don't think so. Maybe this is an unusual one. But I do want to do a bit more reading. I want to make sure that the translation is clear. The way I do this is I take the PDF, I convert it with OCR to text. I then copy that text into a translator, and I try and make sense of what the translation says, which sometimes you can't. But if you know the context, you can often get by with that. I need to just do a little bit more research and get back to you with the final video, which will have the FM alignment, probably RF, definitely IF, probably RF as well, and the completion with this thing in the cabinet. And then a final test perhaps. So I'll be back very, very soon with that. So I want to thank you for your company. I want to thank you for your patience. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. I really appreciate it. Thanks for watching. Bye for now, and stay safe.